Okay, we are given two functions, f of x and g of x, and now we just need to evaluate some expressions. So this video is about using function operations and composition to evaluate. I'm going to try to show you the easiest way possible to do this, and as long as you follow what I do, it really shouldn't be a problem. If you go off on your own, you might have some more difficulties. So let's see. Let's check this out. So this says to evaluate f plus g of 11. So I think the easiest way is to understand what this means, which means you need to find f of 11, find g of 11, and you're going to do this separately. Do them on their own, and then once you have these answers, come back and add them together. That's all you need to do. So you know me, you know I like to color code things, so I'm going to use this dark blue for f, I'm going to use pink for g, and I'm going to work these guys off to the side. So let me create some space. So first I need to find f of 11. So remember, you replace the x with the 11, so the negative is here. Use parentheses whenever you are making your replacements. So negative 11 squared plus 7 times 11. Understand that the square is only going to hit the 11 and not the negative. So this becomes negative, let me do this for emphasis, negative times 121 plus 7 times 11, and then we finish this. So that's negative 121. 7 times 11 is 77. And when you combine these, we get negative 44. So that's what this guy is right here. He becomes negative 44. So you see exactly where he goes. And then I'm going to have to figure out what is g of 11. So g of 11 is going to be done in pink. So let's work that here off to the side. We want to know what happens when we plug 11 into the function labeled g. So when I say g of 11, x is no longer there. This x is now being replaced with a set of parentheses, and inside those parentheses, we are plugging in 11. All right, so 6 times 11 is 66, minus 5, and we get 61. Really not that bad. Evaluating functions really should be one of the easiest things that we do in this course. Plug in a number, do the math, and get your answer. So this 61 is this guy right there. Alright, so when I work this out, this is just negative 44 plus 61. The positive number is larger, so you know that the result is going to be positive. So this is really 61 minus 44, and we come up with 17. So this problem asked us to plug 11 into each function and then add the results. We did. We get 17. That's all there is. Do not make this more difficult. The next problem is doing gf of negative 3. So we need to understand a couple of things here. When the g and the f are right next to each other, this really means that we have multiplication. So it means that we need to do g of negative 3 times f of negative 3. This negative 3, I know it's kind of confusing because there are parentheses here, but there's no multiplication between these guys right here. Okay? This notation, this function notation, says you're going to plug in negative 3 into each function, and when you do that, you're going to multiply those results. Okay? So let's see. We have let's get the setup here. We know that this is going to be a number, and f of negative 3 is going to be a number. So we're going to figure that out, and we're going to figure this guy out, and we're going to do that over here on the side. So let's see. I'm going to start with a g of negative 3. So looking back at the functions we have at the top of the page, that means 6 times negative 3 minus 5. So working this out, negative 18 minus 5 gives us negative 23. So just pop that guy in right here, like that. And there you go. You're halfway done, right? You evaluated g of negative 3, and now we're going to switch gears. We're going to do f of negative 3. So our function f says you have negative x squared plus 7 times x. So as I was saying x, I was just writing parentheses. And inside those parentheses, we are now going to replace that with negative 3. Now again, you've got to be careful about your parentheses, your squares, and your negatives. So here, this square is only affecting that negative 3. The negative and the negative don't ever get to see each other. So this is negative. When you square negative 3, you get positive 9. And now we just finished working this out. So negative times 9 is negative 9. 7 times negative 3 is negative 21. And these numbers combine to get negative 30. And so that now goes right there. So again, take these guys off to the side and work them individually. Then bring them back together and do the math. So negative times negative is a positive. Sometimes we just kind of write that there so we know that we have already addressed the issue of signs. And let's see. 23, really this is 23 times 3, right? So that's going to give us 69, and since that's 30, we just add a 0 to that. There you go. No magic tricks, nothing really special. You just evaluate those functions individually and then bring the answers back and do what it says. If this, instead of multiplication, had said addition, you would have put addition between these two and you would have gotten negative 53. If it said subtract, you would have put a minus here, and then you would have done the subtraction. That's really all there is. Okay, just do the work off to the side, and you're going to be okay. Now let's look at function composition. Okay, so we've got some problems here for function composition, starting with this guy. So this says f of g of 7/3. So this means we need to do f of g of 7/3. It's all about the order when it comes to function composition. This is saying to plug 7/3 into g first, get your answer, and then take that answer and plug it into f. So previously, here's what we were doing. Previously we did like this one, f plus g of 11. We plugged 11 into both f and g separately, and then we brought the answers back. This one works a little bit differently. This one says, don't do them individually. You can't do f yet. You've got to evaluate g of 7/3, and then that value, that result, gets plugged into f. That's what this one is saying. So I'm going to, again, create some separation. And let's do g of 7/3. I know it's got a fraction, but it's probably not that bad, right? So replace the x with 7/3. And now look how lucky we are. Because 3 goes into 6 twice. So 2 times 7, we've got 14 minus 5, which equals 9. That's not too bad. So this becomes f of 9, right? You plugged 7/3 into g. G says, okay, here's 9. Now f can evaluate at 9. So again, we're going to go off to the side here, and we're going to find f of 9. So that's negative 9 squared plus 7 times 9. Alright, so 9 squared is 81, so that's negative 81. 7 times 9 is 63. And these guys combine to give us negative 18. So all of this to equal negative 18. And so in my mind, I view this function composition like an assembly line. 7/3 goes to G to give you 9. 9 goes to F, which gives you negative 18. And again, as we showed in the previous problems, when you have function operations, those guys work individually. This guy does something, this guy does something, and then they come together at the end. But here, we had to take turns. We had to wait for G to finish, and then we got whatever G did to it. All right, let's look at one more example. Here we have G of F of negative 5. So very similar to what we just had, but the order's different. This one says that you have to do G of F of negative 5. So the order here is that negative 5 goes into F, you evaluate that, and then you take that evaluation and you plug it into G. So this does not say G of negative 5. It says G of whatever we get out of here. So going off to the side yet again. So F of negative 5 means negative 5 squared plus 7 times negative 5. And if you happen to forget what that function is, just take a moment to rewrite this. So I'm going to cheat here. This says F of x is negative x squared plus 7x. So I can see what my original function is, and you see that each x is being replaced with negative 5. Okay. So here, this is negative 5 squared is a positive 25. So that's negative 25. 7 times negative 5 is negative 35, and this combines to give us negative 60. So now I have this. I have G of negative 60, like that. So you see that we're not plugging negative 5 into G. We're plugging negative 5 into F, and that result got plugged into G. So now, let's see what happens when I do G of negative 60. But first, let's remember what G of x equals. G of x, let me flip back and look at my notes. 6x minus 5. It's a good thing I wrote that down. So G of negative 60 means 6 times negative 60 minus 5. All right, so this is negative 360 minus 5. These guys are both negatives. They combine to give me a larger negative. So this is equal to negative 365. So I hope that clears up for you some of the differences between function operations versus function composition. With function operations, you're going to plug negative 3 into each of these functions. So you do that off to the side, and you bring the work back together, and you either add, subtract, multiply, or divide. With function composition, however, you plug this number into one function, and then that result gets plugged into the other function.